Hey everybody, before we begin our lesson today, I just kind of want to summarize some of the things we talked about with the ellipse yesterday. So when we're looking at the equation of an ellipse, of course in standard form, because that's where we get like how we graph it, we have x minus h squared over a squared plus y minus k squared over b squared equals 1. Or we have our x minus h squared over b squared plus y minus k squared over a squared equals 1. When the a squared, or the larger denominator, is under the x term, our major axis will be parallel to the x-axis. And when our a squared is under the y squared, our major axis will be parallel to the y-axis. Our center is our H and our K. Now, yesterday we focused on ellipses that were centered on the origin, so we didn't see those H's and K's. Today, after we do our do now, we're going to move on to shifted ellipses. Okay. So we just want to remember one more thing, that our A value is the distance from the center to the vertex. Our B value is the distance from the center to the endpoint. And our C value is the distance from the center to the focus. And lastly, our equation to find any missing information is a squared equals b squared plus c squared. So now we can turn to our lesson. We can turn to our lesson and begin. So ellipses are found in many applications in science and engineering. For example, the orbits of planets around the sun or the shape of bridges. Ellipses also have an interesting reflective property. If a source of light or a sound is placed at one focus, the waves transmitted by that source will reflect off the ellipse and concentrate at the other focus. This is the principle behind whispering galleries. Now, every year in my classroom at this time, I would ask, has anyone ever been to a whispering gallery? And I usually get one or two students that have been. And they're really cool. They're rooms that are designed with elliptical ceilings. So for example, we're gonna do an elliptical whispering gallery problem. So I might as well just sort of show it. So the room would be sort of shaped like that. Okay. And basically, you're going to have your foci. And of course, the edges of the rooms are the vertices. And if you're at one foci, it's going to bounce off and go to the other foci. So what happens is a person can whisper, and that sound can be heard to the person across the room. So with our problem right now, a whispering gallery is 47.3 feet long. The distance from the center to the foci is 20.3 feet. Find an equation that describes the shape of the room. How high is the room at the center? So we have two questions that we really have to answer. Find the equation, and then how high is the room? So we want to make sure we answer these two questions. Find an equation. We did these problems yesterday. Okay. So now it's just taking the words out. Instead of the information being given to us, we have to figure out which piece is what. So a whispering gallery is 47.3 feet long. So that means my distance from one vertex to the other vertex is 47.3. So the distance from the center to that vertex is going to be my A value. And what I'm going to do is I'm going to take and divide that number by 2, and I get A is equal to 23.65, and that's just calculatable. The distance from the center to the focus is 20.3 feet. Let's change our color a little bit. Center to focus is 20.3 feet, so that means my C distance is 20.3. Find an equation, so now I have to figure out which one to format it in. Is it the x squared version or the y squared version? Well, this is going to be the x squared version centered on the origin. So I have x squared over a squared plus y squared over b squared equals 1. And lastly, we're going to now start plugging in our information. X squared over, now this might be hard for you to understand, but when you plug this into the function, if you want to, it's not a function, but when you plug this into the equation, you can just put it like that if you want. Okay. Saves you a lot of like problems. You know, you don't have to copy down so many decimals. I need to now figure out, right, what my b squared is. I go back to yesterday's lesson, a squared equals b squared plus c squared. 23.65 squared equals b squared plus 20.3 squared. All you have to do now is solve for b squared. B squared is going to equal 147.2325. And b squared can be put in that as that number. Now, if that makes you uncomfortable to have 23.65 squared and the other one not, then just square this out. And don't worry that these numbers are messy. We're really not doing anything with it. I'm not asking you to graph it. It's just finding an equation. So that answers the first part of the question. Find an equation. Now, how high is the room at the center? Think about it. How high is the room at the center is going to be the endpoint, right? Isn't this going to be the height of the room? That's going to be my height. I know that this distance is b, so if b squared equals 147.2325, then the height is going to be b. I'm just going to take the square root of that. I'm going to go up here. The height of the room, sorry, I didn't give you enough space, is going to be 12.134 feet. So that's sort of a twist on a problem, like the type of application problem we could do with this information. True to form, today we're going to now move on and we're going to graph shifted ellipses. The practice is going to be the same. We're going to find the center, the vertices, the endpoints, and the foci, and then we're going to put all this information together. Yesterday was easy because we were centered on the origin and our movements were very easy. Today is going to be a tiny bit tricky, but if you stay organized, you should be okay. On my paper, I'm going to put a place for center, vertices, endpoint, and foci. Now, when I go to identify my center, I want to remember my center is going to be my H and my K. True, or just like we did with the circle, we're going to take out the opposite, right? Because it's x minus h squared, y minus k squared. So my center here would be -4, -2. I might as well put that on my paper right away so I don't mess up. -1, 2, 3, 4, -2. Everything is going to move off this center, whether it be in the x direction or the y direction. We're going to move from this new center. Now we go back, identify your larger denominator. Your larger denominator gives you your a squared. A squared is 9. So my a movement, okay, the distance from the center to the vertex is plus or minus 3 units. Since I'm under the x term, I'm moving in the x direction. Plus 3, minus 3. These are my vertices. If you want to count boxes and get your ordered pairs, if you want to do the math in your head off the vertex, basically what's happening is I'm going -4 plus 3, -4 minus 3 to get the new x value. So I have -1, -2, -7, -2. The y value is not going to change, only the x value. my endpoints, b squared equals 4. So b is plus or minus 2. I'm moving up 2 units and down 2 units off the center. Up 2, down 2, endpoint, endpoint. This time, the y value of the center is changing. -4, -2 plus 2 is 0. -4, -2 minus 2 is -4. Now we have to go back in and find the foci. Remember, a squared equals b squared plus c squared. 9 equals 4 plus c squared. C squared is 5, so c is plus or minus radical 5. Similar to yesterday, I'm going to connect my dots. Now I'm going to plot my foci. Once again, we're moving radical 5 units. So that's square root of 5 is in between 2 and 3. 2 and a little bit. 2 and a little bit. Here's the confusing part. I started at -4 and I moved radical 5 units, but my y value is still -2. I started at -4 and I moved in the opposite direction, radical 5 units, but my y value is still -2. Now, some of you may prefer, and this is what I was mentioning yesterday, I prefer, I start at -4, I go up and down, radical 5, my y value stays at -2. That mathematically represents 2 separate points. If you prefer to write your ordered pairs that way, I have no problem with that. And we are done. I do not want to see decimals on your page. I want to see you leaving things with the ordered pairs, with the radicals. We're going to jump now because the graphing is very repetitive. You have homework problems in your practice packet to practice if you want. So, actually, we're going to now try to do it by completing the square. So in order to graph an ellipse by hand, it must be in standard form. Standard form, guys. So we must complete the square. So if we're given an equation that's in general form, we have to complete the square. You did this in your Algebra 2 course. Okay? We're going to review it really quickly and apply it to the equation. We want to group like terms together and factor if needed. Bring the constant to the other side. Leave a space to add the missing number. Find a number to add. Remember, we're going to use b over 2 squared. Write in factored form and then divide each number on the right side of the equation to get it into standard form. Now here's directions to look back at. Hopefully a lot of you, once we start this problem, hopefully a lot of you will remember what we're doing. We're going to group our terms. So I'm going to take anything with an X in it and I'm going to group it. Then I'm going to take any term that has a y in it, and I'm going to group that together. And then I'm going to move my constant to the other side. Now I look at my terms. So I have a 4 and an 8. I can take out a GCF. So I'm going to factor out a 4. And inside parentheses, now I'm going to leave a space to add a number. I'm going to move on to the y term. I don't have the GCF this time because I don't have a number in front of the y. I added 2 spaces on one side. I have to add 2 on the other. Sorry, I'm going into my picture. Find the number to add, right? We need a number. So I have -2 over 2 squared. That's going to be 1 squared, which is 1. Whatever I do to one side, I have to do to the other. In this case, though, I have to remember to multiply it by this number out front here before I add it to the other side. Middle term, divide by 2, square it. 4 divided by 2 is 2, 2 squared is 4. I don't have to multiply it this time. Whatever I do to one side, I have to do to the other. The next step will be you're going to take this and write it as x minus 1 squared. Remember, that would factor into x minus 1 times x minus 1, which is x minus 1 squared, plus y plus 2 squared equals, clean up the other side, negative 4 plus 4 is just plain old 4. Now we want to divide through by 4 to get it into standard form and simplify. Sorry, our work's going to be a little squishy. We have to identify our center, our vertices, our endpoints, and our foci. My center is my h and my k. 1, negative 2. I'm going to go ahead and plot that right away. That's my center. To get my vertices, my larger denominator is under my y value. So a squared is 4, and a is plus or minus 2. So I'm going to be moving in the y direction off the center. Up 2, down 2, vertex, vertex. The coordinates of the vertices. 1, negative 2 plus 2 is 0. 1, negative 2 minus 2 is negative 4. My endpoints, b squared is 1, so b is plus or minus 1. So I'm moving in the x direction this time, horizontally. Over 1, over 1. Endpoint, endpoint. I could connect. I don't know if you've noticed, but I do it in different order every time. I'm sorry. My endpoints, my x value stays the same. I'm sorry, my x value changes this time. Ugh. I don't know what I did here. Don't worry about that highlighter. I'm just going to have to leave it. My endpoints are 1 plus 1. So I have 2, negative 2, and 0, negative 2. And then my foci are going to be the c movement, a squared equals b squared plus c squared. So my a squared is 4 equals 1 plus c squared. C squared is 3. So my c movement is plus or minus radical 3. Don't worry about it, right? It's just, what is the square root of 3? It's a number between 1 and 2. Up 1 and a little bit. There's my focus. Down 1 and a little bit. There's my focus. Squishy picture. Not a big deal. Try to be as careful as possible. The y value, the x value of the focus doesn't change. Remember, we're moving in the y direction. So we're starting at negative 2, and we're moving up and down radical 3 units. Okay. So sketching the ellipse is really not that crazy, but you really have to be careful that you always plot your center and move from there. Uh-oh. Find an equation. Something happened to my copy. Did I cut that? I'm not sure if your copy is bad, but basically the directions I have, find an equation. So the center is 2, negative 3. focus at 3, -3, and a vertex at 5, -3. I don't know if I messed up my document or what happened there, but on my printed lesson, this is the information I have. So finding an equation, we're going to do the same thing we did yesterday. To find an equation, we start by plotting the points. My center is at 2, -3. I have a focus at 3, -3. And I have a vertex at 5, -3. So basically, this is going to give me, first of all, I'm using the a squared under x squared. Because my ellipse is lying horizontally. And now I'm going to find my values and plug in. Well, A is the distance from the center to the vertex. So my A value is 1, 2, 3. Oh, and my center is, so I could plug this in right away. X minus 2 squared plus y plus 3 squared equals 1. And now I'm just going to kind of find the missing components. So if A is 3, A squared is 9. C is the distance from the center to the focus. So I'm moving 1 unit. And remember, A squared equals B squared plus C squared. And this is what we're going to use to fill in that last spot there under the Y. A squared is 9 equals B squared plus 1. So B squared is 8. And we're going to pop that guy right underneath. And I apologize if we're a little messy, but there's your finished product. There's your equation. Okay. So this, kind of ends our discussion on the ellipse. Please try your practice problems, and we will see each other soon.